and then we'll get into our lab, and then we'll start talking about projectiles when we get back. So let's just do a cliff problem, a typical cliff problem. How high should my cliff be? 80 meters, and what's the velocity of my ball?
0.
10.1. Just make up a velocity. 10.1.
Which we're throwing the ball up from the cliff?
Yes.
Okay.
Have we done this type of problem before?
No. Well, we dropped it, but we didn't throw it up.
We didn't throw it up from the cliff. Okay, good. Well, this will be good then. Meters per second, sorry. So we're going to take a ball from the top of a cliff and we're going to throw it upwards. Just as easily I've thrown it downwards, and it's the same type of problem. So what do you want to solve for? Final velocity where? At the bottom. Alright, so let's solve for final velocity here. So first thing, in case you're not sure where to start the problem, identify where you're starting and identify where you're finishing. So you can figure out what's initial and what's final. And then ask, what do you know about the problem? Do we know our final velocity?
No.
No. Do we know our initial velocity?
Yes.
Yes. What is it? 10.1 meters per second. Is that up or down?
That's positive.
As positive, it's up. So we'll just leave it as positive. Our acceleration?
-9.8.
9.8 meters per second, and that is negative. Why is it negative?
Because gravity is always
Because it's directed downwards. Time. We don't know. Jake. Jake. Shh. Change in position.
Wait.
Well, it goes up.
It goes up.
We don't know.
No. Wait, you throw it up though. Because it's good.
Remember what this is. This isn't distance traveled. Right, it's displacement. It's from where it starts to where it goes. We start here, we finish there.
You're saying, but like, wouldn't it mess with the equation because we did that first?
Because it's going up and then coming down?
Yeah. Oh, but you're just finding, I think so, okay.
Finding how far away it is from the point where it started.
If we wanted to know about the distance traveled, like how far it went, then we'd have to do more calculations. But as long as you have your directions right, positives and negatives, the formulas will take care of all the other nonsense. Now, is this a positive or a negative 80? Negative, because I'm going down. If you ended up with a positive 80, well, we'll look at what you should get when you get a positive 80.
So is it always going to go down? Is it always going to be negative displacement?
No. Next problem we're going to do, after this, we're going to do one with a positive. So we're looking for final velocity. What's the formula that involves? Final velocity, initial velocity, acceleration, and displacement. Yep. Final velocity is what we're looking for. Initial velocity, 10.1 meters per second, squared plus twice the acceleration, negative 9.8, times the displacement, negative 80 meters. Do that math one. Okay. Somebody do the math. Alright. What's the number? what?
40.87.
40, is that after taking the square root of it?
Oh, sorry. It's
Yeah.
1,670 is without.
And so the final velocity is at 40 point something, 87?
87.
The second one that I want to do before we get to the lab is throwing the ball straight up. So what we're going to do is we're going to throw the ball up, and we're going to have somebody up here who's going to try to catch it. You'll see the problem is worked the exact same way. Just keep your directions correct, and you won't have any troubles with it. How fast do you want to throw the ball? Well, actually, let's do this. Say we don't know how fast we throw it. How high do you want to throw it? Let's give me a number here. How high up is your friend? 65 meters. And the question is, how hard do you have to throw it? How hard do you have to throw it in order to get it up to 65 meters? So what is my initial velocity now? What do we know? No distance? 65 meters, is that positive or negative? Positive, because we're going up. What else? Acceleration is negative 10 or negative 9.8. Final velocity will be 0. And not because he's catching it, it's because if we throw it up, we just want to get it just barely up there. So we can assume that it stops when it gets up to that height. He can catch it when it stops. Initial velocity is what we're looking for. Time, we don't know that either, but we can solve for it. Now that we have all our values, what do we use to solve for initial velocity?
We could use the VI squared.
Same thing we just used. Final velocity is 0. Initial velocity squared plus 2 negative 10 meters per second squared times the change in position, 65 meters. Move that over. Negative VI squared equals 2 times negative 10 meters per second squared times 65 meters. Jake, am I boring you today? Negative VI squared equals 1,300. Negative. Right? Alright, I tend to go a little fast on these. Is everybody still with? Don't need to take the square root of a negative number here. Negatives on both sides to make everything positive. So the square root of 1,300 is our answer. What is that?
36.
36.